Hi everyone, this is Edward with DIYev.com. That's like DIYelectricvehicle.com. And the reason we do videos for this website is we show you about electric vehicles, electric trucks and cars. And then we also show you the technology of what it takes to power these vehicles, whether it's solar panels or something like what we're looking at here, which is called Peltiers. So what we did is we purchased a couple of Peltiers, and that's a French term, so I think the French developed this. And that'll probably explain why we're getting these results. So you can purchase these on eBay or many other sites. It's either called a TEC or a TEG Peltier, which is thermoelectric generator. And these units, TEC, cost right around $2.30 each, and you can buy them in a pack like that. And with the TEG for the generator, they cost around $3 and something each. But the way they work is, on this side, you're going to have the cold, and on this side, you're going to have a hot. So you have a cold and a hot, and that generates electricity. And what they have on the website, and anybody that sells these, they'll give you the actual data or the spec data sheet. So they say once you get to a 100 delta, that's for example 0 degrees Fahrenheit to 100 degrees Fahrenheit. That is a 100-degree delta. So that means you would be 0 on this side and 100 on this side, and what they say in their spec sheets is that you're going to get 4.2 volts at a ½ amp. That's what they say in the spec sheet. So let's put this to the true test, and we're going to see exactly what we get. So here's our apparatus. You're showing 50 degrees on the cold side, which is inside here. You can see the way we have it. Let's put our thermocouple back in there. And then you have the hot side, which we have a heat sink over here, and we can heat hot side with a heater, for example. So then we have positive and negative leads coming down to our DMM, and you can see we're getting about 213, it's all over the place, 173 millivolts. That's not a volt, that's a millivolt. So now we're going to put it to the test. We've got to get this 45 down. I want to get it to about negative 40. I want to give you a true 100-degree delta. So what I'm going to do is grab this, and I'm going to put some liquid nitrogen in here. I'm going to put some liquid nitrogen in. You got to be very careful with this, because touch it for too long, it will burn you, just like fire. So that's why I'm wearing this glove. If I hold it too long, it'll burn myself, just like a burn. It'll blister up and everything. So you have to be very careful with liquid nitrogen. Never ever stick your tongue to this. I've only done that 3 times, and I plan on doing it again. So we're going to put the liquid nitrogen right here, and we're going to show you how it dances around. Look at that, just dances around. You put it on, it's going to start boiling. Listen to it boil. It's boiling like crazy. Once you put it on an insulator, it doesn't boil that much. That's why I use some cryogenic insulation here. So what we're going to do is we're going to pour the liquid nitrogen inside here to start a project. You know, it's just boiling off, nothing to be alarmed about. But put this over here, but we have to make sure our thermocouple's inside, remember? So we make sure the thermocouple is inside. That way we're going to be able to get a temperature reading. We use a Type K thermocouple with a Kapton material, and you can see the temperature's dropping. If I put my hand on here, I use some aerogel from NASA for the insulation. I get some good insulation factor here. That should get down about negative 20 pretty quick right there. So you're going to see it drop and drop and drop. And if you look at the DMM at the same time, put my hand over it, you're going to see we're about, because we do have a temperature difference, we're about 247 millivolts. So what we want to do is start applying some heat at the same time. So as you can see, we're applying some heat. So we're going to try to get this up to the 4 volts. So as you can see, we're negative 30 over there. We're up to almost, trying to get to 1 volt. Come on, you can do it. Come on, 1 volt, 1 volt. There we go, 1.056 volts. So let's see what our temperature is on this side. So yeah, we're 123 on this side, and we're negative 28 over here. So we're definitely at our 100 delta. So we have accomplished on volts, as you can see, volts. If I keep it up to about 124 Fahrenheit, I can get about 1.2 volts. So as you can see, it was -20 here, 120 here, and we were getting, with that kind of delta, that was almost 140-degree delta, we're getting about 1.2 volts. So there you go. On that part, you're getting 1.2 volts with 140-degree delta. So that's what we're receiving on that. So now we're going to do another video, and we're going to show you what we get on amps. We're probably going to have to measure on microamps as well. So that's the next video. Okay, we have everything set up. We just showed you volts on the Peltier. Now we're going to show you microamps on the Peltier. This is one Peltier. So what we're going to do is we're going to add a little bit more liquid nitrogen. So I'm going to pick that up, pour this in here. Empty that in there. Let's drop that temperature down, hold it down a little bit. You see we're back to -20 already. So we're going to heat this other side. So we're probably up to about 84. Let's give it a little bit more. Okay, so now what we're looking at about, that's kind of hot right there. We're looking at about -7, -6, and we're looking at about 116 on this side. So that's your 100-degree. So now what we're reading is 250 microamps. You can see it's connected. More than welcome to look at the connection here. So you can see it's in series over here. So you can see everything's connected to where we can read our amps. That's microamps. So now that you've seen the volts and the amps, and we're going to go in there and look at it on a board, and we're going to do the math, and we're going to tell you how much it cost, and maybe even show you a comparison of how much it would cost just to do maybe 1 amp with 3 watts, whatever. But we're going to show all that to you, because now we've proven to you exactly what these Peltiers get. We showed you the volts, and we showed you the amps. So let's go to the board. Okay, so we're back at the board, and as you can see, we're from the Peltier, these are the results we got. Okay, so now we got it on the board. Remember, we had a 100-degree difference. So we had a negative side, -40, and we had a positive side right around 120. We were definitely within this 100-degree delta. Now, our first results yielded in volts. So we were getting about 1.2 volts VDC. And on the amps, that's the second video we did. That's the second one we did. And we yielded about 332 microamps. Or you can look at it a different way, 0.003 amps. So we're going to take this a little bit further. So what we want to do is kind of compare it to a solar panel. So we know solar panels give us about 12 volts of power. So what we're going to do is we're going to run these in series. So if we run 1.2 and keep running the Peltiers in series times 10, 1.2 times 10 is going to give us 12 volts continuous power from that. Now the second thing we have to do is get our amps up. 0.003 is not going to be enough to do anything. So now what we do is we have to run these in parallel. So we have to run 334 of these in parallel. So that's 334 times 0.003, 1 amp right there. So here we go, 1 amp. So here's our final results. And so you're looking at 10 times 334. Let's see how many Peltiers that's going to take. Do that right in our head if we wanted to. 3,340 of those Peltiers that I showed you. You have to run them in series and parallel to get your 12 volts and your 1 amp. And your final results after all that is 12 watts. That's all you're going to get. So we take 3,340. I paid about $2.30 per Peltier. That's what I paid, times 2.3. We're right around $7,682 for 12 watts. So the Peltiers are pretty much worthless for generating electricity. I think if you're going to try to use them to refrigerate a small cup holder or something like that, they're good for that. I think they are used for that technology, but there's been a lot of people saying they could generate electricity using this semiconductor type chip, and then having liquid nitrogen on one side and hot on the other, or just blowing air across it. There's been a couple of people out there doing that, even raising money to do something like that. But do your due diligence, do your math. That is totally debunked. So you're looking at about 7,000. We did some solar panels. We were getting about 70. So that means you'd spend about $70,000 to equal one $200 solar panel if you're using Peltiers. So the solar panels are the way to go. So stay tuned for our next videos, and we'll see you later.